Hello, everybody. My name is Jeff Catlin from Edgecore Networks. Oh, thank you for that, too. And today my talk is going to be on the world's first Whitebox OLT. Maybe. Let me see if I can make this work. Oh, I guess I'll have to keep coming up here. Okay, so just a bit about who Edgecore is. So you may hear Edgecore and Acton kind of used interchangeably. Acton is the parent company. Edgecore is just a wholly owned subsidiary of Acton. Acton is a networking ODM, has been around 25, 30 years. It's very good at building networking products, needed a way to get their technology to market. Edgecore is simply just a brand name to get the technology to market. So if you think of it that way, it's very simple. So as I was thinking about this talk and preparing these slides, I thought about the placeholder Sarav put in for the world's first Whitebox OLT. And I spend a lot of time now explaining what this product is. So I think perhaps a better description would be the world's first open and disaggregated OLT. So I'm going to try to touch on those two keywords, open and disaggregated, throughout the talk, and hopefully explain what it is, and also what it isn't. So just an overview of the product. It's a 1RU box. It's 16 ports of XGS PON. Has 400 gig uplinks in the middle of the box. Has your standard console port, USB port, and out-of-band management port. On the back, it's got typical redundant power supplies and fan trays, which are the FRUs. And at an overview, that is the box. Okay, we could leave it at that, but we'll go just a little bit further. Okay, so let's touch upon those two words, open and disaggregated. So first, open. So to us at Edgecore, open indicates a couple things. It indicates open software components, but also indicates an open hardware design, right? So it's more than just open software. So this hardware design started in an open community. It happened to start in Open Compute. And the way the open communities work for hardware designs, it usually starts with a sponsor that does the community definition of the product. That sponsor could also be the vendor, but in this case, the sponsor was AT&T. So they come out with a specification. The specification goes back and forth a few times between the community members, potential vendors. At the end of that, back and forth, the sponsor will release their spec to the community. The vendor will release their specification and their hardware design files to the community. Right? So it's a totally open hardware design. Okay, and that's kind of how the hardware flow goes at a high level. So we at Edgecore have been very active in open hardware designs. This is kind of just a snapshot of our hardware designs. The OLT that we just talked about, we contributed that to Open Compute through the OCP Telco group. We did that last month, I believe, at the meeting in Texas. So now the OLT design is a true open hardware design. So what that means is all the design files are publicly up on an Open Compute server. Anybody can go to that, download the hardware files, okay, the Gerber files, the board files to reproduce it. So someone can manufacture that design. Someone can take that design and enhance it or change it as they see fit. Right? So that's a totally open hardware design. What the hardware looks like inside, there's a few key components, and usually the key components in these types of designs, of course, have heat sinks on them, so you can't really see what they are. This design is based on a Broadcom switching chip, so it's based on the Qumran AX silicon. And that does all the switching functionality between and for the PON Mac chips in front. So in front of the switching silicon here, you have Broadcom codename Maple GPON Mac chips. So there is another open 1 gig OLT design that was done. It's not really open. I don't think they published the files, but there's a 1 gig design based on some other silicon. And that design doesn't have any switch in it, so all the uplinks that are from the Mac chips actually go out, and you have to have a switch on top of it to switch between and for the PON ports. But in this design, there is an actual switch chip in there. The switch chip is a high buffer chip. It has great quality of service features. So even though in this design, a lot of that PON traffic may just pass through that chip, and that's really used to aggregate that PON traffic up to the 100 gig links, there's plenty of functionality in the future that can be exposed in this piece of switching silicon if that's desired. Okay? And the other things in the heat sinks are, CPLDs and FPGAs to run the low-level optics and communication paths in the design. Okay? If there's any questions, certainly interrupt me and we'll do that. Okay, so we talked about open. So for us, it's open hardware. Disaggregated. So in open networking, disaggregated, of course, means separating the software from the hardware at a very high level, right? Disaggregation, though, doesn't necessarily mean it's open software. And it does not really indicate where this disaggregation line has happened between the hardware and the software. So this is what kind of becomes confusing. I spend a lot of time explaining to customers, especially on the OLT. So we'll take a look at what disaggregation at least means to us. So in disaggregated software, there's plenty of options in the market today that are commercial. They're not open source, but they are disaggregated because they don't come with the hardware, and you can download those on the hardware through an ONI install mechanism. So there's a snapshot here of the disaggregated software pieces on the top that are commercial, so they're not open source. They're for a fee and they're for an annual maintenance fee. Okay. There are open source alternatives that go on a Whitebox or a disaggregated piece of hardware. Okay, these are listed at the bottom. Of course, the cord stuff through the Linux Foundation is over there. OpenSwitch. There's some other things. There's some things from Open Compute, Sonic, and the switch abstraction layer. Those are all open source. There's also some components here that are enablers for an open source software package that we utilize in the software for the OLT. So I kind of listed those there. There's the ONI install mechanism. There's an SFlow agent from Inmon. There's the Open Optical Monitoring API. So there's all these open source pieces floating around out there that can be assembled together in an open source fashion in an image to run a product. Okay, so we have disaggregated software, we have commercial, and we have open source. So two different disaggregated pieces of functionality and the way they're disaggregated or the way they're offered. So the software that we provide for the OLT, of course, we start out with the hardware, and then we put some of those pieces on top of there. So we start out with Open Network Linux, okay, and that's a standard Linux distribution that was accepted by Open Compute. In that distribution, there's a function that will go out and it will monitor the fans and the power supplies and the status LEDs for the platform. So that's included. We include the ONI installer in our diags package, and all that stuff is open source. The red boxes here are part of that software. So you need SDKs on top of the switching silicon and the Mac chips. Those are not open source, so they're provided by the silicon provider. In this case, it's Broadcom. So that's the very basic package of what comes with the OLT. Okay, so now we have a Linux distribution on there. And then we add some other components. Some of these components were on the left side of that previous slide as open source components that are available, right? So we have, I call it an agent. It's a Volta translation piece here that talks to Volta up above, and it translates those information calls from Volta to BAL API calls. So on top of this SDK, there's a API from Broadcom, which has been open source, at least the top half of that API, right? So that's for communication into the OLT to configure the switch chip and the PON chips, okay? And the agent rides on top of that for Volta. And then in here, we also put the Open Optical Monitoring piece, which allows you to manage your optical plugins for inventory, status, power, that type of stuff. We have a Redfish API, which we put in there that allows those hardware primitives for power supplies and fans and that kind of stuff to be available for some other application in the network to come down and get that information. We have the SFlow thing that we can include with this. to get some S-flow type statistics out of the switching silicon, the Broadcom switching silicon in there. So we take all that and we wrap that up together, and that becomes the software for the OLT. Okay, so that's what's available for the OLT, and of course above that, you have your Volta and your cord controllers and the likes of everything you guys have talked about here for the last couple of days. So I think as important, and what I find I explain to customers a lot, as important as what's in here is what's not in here, right? So in here, you don't see OMCI, right? So a traditional OLT, right? You would have an OMCI blob in here. You don't see SNMP and MIBs. You don't see a CLI, right? That you would come in and configure the switch chip and the PON chips and the likes of that. So all that type of functionality now is outside the box and runs in the compute nodes. So a traditional OLT, it's not, okay? A disaggregated OLT, it certainly is, okay? Because all that functionality now that's not needed to be here is removed from this device, which simplifies this device. So we've gone through a lot. So we've talked about the hardware being open. So the hardware is certainly open. That's come from an open source community, open compute. We talked about the software that runs in the OLT, and for the most part, that's open source, except for the pieces that cannot be because of vendor proprietary reasons. Okay, we've talked about, or you guys have talked here and will over the next day, the open source software that runs outside of the box to control the box, right? That runs up above in the compute nodes. So all those things together are what makes an open and disaggregated OLT. Okay, you need all of those pieces to make this function. So you can't just buy this OLT, throw it on a desk and connect some ONUs to it and configure something through a CLI and then you're off and running. That's not the intent with this. Okay, so all of this was done, okay, within a community. So it's taken a lot of different open source communities to bring this together, from hardware to software. It's taken a lot of vendors to bring this together, some of which would normally compete together in the market. So some of our competitors have worked to make this happen. So this is truly a community approach to bringing a product and a platform to market, which is different than any OLT before. So I believe that is it for my slide. So hopefully I've explained that what a Whitebox OLT here is. It's truly open for both the hardware and the software, and it's disaggregated, and where that disaggregation line is, okay? So the software is separated, and most of the traditional functions don't live in the OLT anymore. Okay? I can take questions.
I'll ask a non-technical question.
Sure.
The title is the world's first disaggregated open
Whitebox OLT. And that's a good title, but that confuses people on what is a white box, right?
My question is, do you see others following? Will there be 20 Edgecores building Whitebox OLTs? Or do you think, I don't know, it's an evolving space and the market is open.
I think, I'll give you my honest answer. I think if we make the software, the entire software stack that I showed in the last slide, the embedded software, the external software, and wrap that all together and make it work, I think yes, competitors of ours will follow and make products, right? This same model for a GPON OLT is true for a G.fast type of box or some other aggregation box at the access layer. So it doesn't have to be just GPON. Okay, it could be other technologies as well. So once, as a community, we come together and prove that this works, right? There's benefits for vendors, there's benefits for consumers, and there's benefits for the open communities to make these types of products. So I think there will be business here.
Yeah. So I also wanted to explain the white box part. So like every speaker over here knows, I put up some title, right? And I gave the option to the speaker, you're not bound by that title. You can change it if you want to. Jeff didn't change it. But so my concept of white box is very simple, right? So you have black boxes, which are vendor proprietary hardware and software, and so you have no visibility in there. But then Jeff had this excellent slide, which also showed that you could have open hardware, but still proprietary software, right? And so in the industry, at least in the switching world, a lot of people refer to that as gray boxes, or sometimes referred to as bright boxes. What I believe is that you get to truly white boxes when you have open hardware and that open source software. And the fact is that in what we have done with Volta right now, with the Edgecore box, literally most of it is open source software. The only part that is not open source is the part that has Broadcom's SDK involved, and that has to be closed source, but it offers that open API, that BAL API that the next speaker, Kim Kempf, will dive into a lot more detail. So basically, it's what I wanted to get to was the white box explanation and how Jeff, explained that in a much more detailed way, but they both apply. So Jeff, I actually had a question for you. Is there any plans for moving to the Maple 2 chip from Broadcom, or even getting into the ONU space at Edgecore?
So ONU space, currently no. I don't think we have plans for that. That's a very full market today with ONU providers. It's very competitive. There's established players there. I suppose there's the opportunity for a white box ONU, right, to go along with this, but we don't make those today. We will do follow-ons to this platform. Quite honestly, we're seeing a lot of interest in a 1 gig, 2.5 gig platform to go along with this, not just 10 gig. So there's a lot of business models out there that show that 1 gig and 2.5 gig PON is still very attractive for operators over the next 2 to 4 years, 5 years, right? And it's not all going to go to 10 gig PON. There's certainly a need for 10 gig PON. So, the Maple chips in here can support multiple, I forget the exact number, 1 gig, 2.5 gig PONs. Yeah, 10, 2.5, so it's fairly high density. So I would envision perhaps we take this design, or someone could take this design, right, and change the front end so those Maple chips break out into more PON interfaces for slower speed PON, and that would satisfy some use cases. Now, whether we'll do that or someone else will, I guess that's yet to be seen. Certainly for the Maple 2, a follow-on chip that has higher density and higher capacity, that's always going to be needed. Bandwidth never stops, so we'll look at doing that as a follow-on to this as well. But right now, I think the most interest we're seeing is the lower speed PON. Be honest with you.
That's also including Ethernet-based PONs, EPONs.
We haven't. The operators we're talking to, maybe they're just keying off that this is a GPON box and just asking for the higher density, lower speed GPON. I haven't been involved in any EPON discussions.
As far as I know, the Maple does do EPON as well.
Yeah. Yep.
Any other questions?
Even though we try to play with the box, right? So when I'm just wondering what's sometimes confusing is what's Edgecore's role versus Volta's role, right? So when someone buy a box from Edgecore, when they turn the power on, then what do they do? So is that Edgecore will provide documentation? So I'm trying to address the documentation portion of it. Is that
So
the step-by-step loading all those components,
right,
to turn off your device? I'm sure you probably have received a lot of customer support calls.
There's a lot of support calls on this because it's a little different than the Ethernet switch white box or disaggregated model. That box we ship a lot of, and they come with diags and an ONI installer. And there's a quick sheet to where to go to oni.org and how to run that and download it off. So that's pretty standard in the industry. This, if you go back to that software picture I showed, is a little different where today we're offering the OLT the same way with just oni and diags. But when we work with all the people that are doing POCs and want to kick the tires, we end up getting involved in providing that other piece of software. So, with ONL and with all those other pieces, right? So I guess that's a question. I guess I don't know who answers, but we could provide that as a binary installable package. It's all open source components. We can pass through the SDK as we do today with our other stuff. So we could offer that. I think you guys offer that as well. Yeah.
So in fact, ideally, we would want to follow the same model that we have been following for the Whitebox switches. So I've been working with Jeff for over 2 years now, and we started working on the leaf spine fabric first, and now we've moved to the OLT side. But what we do on the fabric side is that what we tell folks is that you can go and buy Edgecore hardware, and they will give you the software. Or you can go and buy their hardware, and you can get the software from us. We have it up on our wiki. These are downloadable binaries. The open source parts are already there on GitHub, but the easiest way to do for you to get started is with the binaries. So if you wanted to, you could compile all the software, and for the non-open source parts, you would have to have the with Broadcom and then get their software and compile it, make changes, and so on. But the easiest way for you to get started is just have the binary. And that's what we've been doing for the last year or so, actually more than that, on the switch side. Now with the OLT, it's just very new. We just got it to work less than a month ago. And so eventually we want to get to the same level of comfort that people have with the switch side, to also have that same level of comfort on the OLT side, which is not there yet. So right now it's still a cumbersome process to get the right software, to be able to compile it, to load it onto the switch, have that work with Volta and so on. But give us a little bit more time and we'll get to the same level of comfort. Any other questions for Jeff? Yes, Kim?
This design, does it support NG1 too?
I think the Maple does. I don't know what changes would have to be made, if any, to the hardware design. I think there may be. I don't see the right Broadcom guy in the audience, but I don't know if there is a different SKU for the multiple GPONs and the EPONs and that stuff. So it's pretty specific. Yes. Somebody else have a question?
No other questions? Yeah, please.
Yeah, so when you have a switch from OCP to be accepted hardware, you have pass and test provided by OCP. It's the same thing for this box. You have some kind of test standard. You need to pass to be accepted OCP hardware.
Yeah, there's a test plan that goes along with this. I submitted the test plan to OCP. The test plan that we do for the switches is, I think it's pretty high level. It's connect some devices and do a snake test and do some other things. And once you do that, if you have no errors, the hardware is proven to be functional based on how it was intended to be used. So that's kind of the test plan. We don't really supply detailed manufacturing test plans and that kind of stuff yet. Yeah, there is a test plan for that, yeah.
Jeff, in the software stack, we saw that there's this bar in between. Have you ever thought, or Saraf, have you ever thought about talking directly to the SDK of the Qumran and the SDK? I suppose that's something like an SDK for the Maple. Why does there need to be a bar in between that
Yep.
features from
That's
the
my
You want to take it?
Oh, that's right. There was a lot of discussion on that. There was a lot of, I could just give you, there's a lot of discussion on that. And to talk to the SDK, you'd have to expose some proprietary Broadcom information on the wire. So as far as I'm concerned, there needed to be this adapter above it that was open that you could program to, so it wouldn't expose any proprietary information.
Because the Volta adapter right now that talks to the Edgecore box, the Volta adapter is completely open source.
Mhm.
So if you start putting SDK stuff over there, it cannot be open source. That's so. I mean, Kim, the next speaker, will dive a lot deeper into that. So, any
Any other questions for Jeff?
All right, thank you very much.
Thank you.